Hello, good morning everyone, and once again, welcome to the electronics world. Our lesson for today will tackle all about the designing and constructing of an efficient appliance protector device. It is efficient class because it doesn't use a transformer, but instead a capacitor that steps down the voltage from the outlet. While this type of appliance protector device uses a transformer, which makes the device much bigger and heavier, and actually it is more expensive because the total expenses of this type of appliance protector triples the expenses of this appliance protector. Our lesson for today's class will be focused on this type of appliance protector device. We have actually here the complete schematic diagram based from this appliance protector device. This circuit diagram is actually consists of two important circuits. We have here a 555 timer circuit that will control the operation of your electronic appliances. And the second circuit actually is this power supply, which is a capacitive type of power supply that supplies power to this 555 timer circuit. So, what is this 555 timer? 555 timer actually class is a versatile monolithic IC. It is versatile class because based from this block diagram of IC, it has two types of circuits. We have here the flip-flop that represents the digital circuit. And we have here the comparators that represent the analog circuit. Moreover, this 555 timer IC is a multifunctional IC. It can create or makes lots of projects. Actually, one of the applications of this LM555 IC is the appliance protector circuit. This appliance protector device uses 555 timer IC that operates the circuit. So, how this name 555 is derived? Based from this block diagram, there are three resistors that are connected in series. They are connected from the negative side of the power supply to the positive side of the power supply, wherein each of the resistor is having 5 kilo ohms resistance. There are actually 5 kilo ohms here, which are connected in series. That is how the name 555 timer is derived. Then you have here actually the complete schematic diagram, the internal circuit of this IC, 555 timer IC. Actually, it is an integration of 25 transistors with 15 resistors and 2 diodes. And we have here the external terminals, the 8 pins or terminals based from this actual IC. We have here the actual IC. It is actually a dual inline package where each side is having 4 pins with their functionality. Number 1 actually is the ground, and number 8 is the positive side where the power supply is connected. This IC can be supplied with voltage ranging from 4.5 volts up to 15 volts. The number 2 pin of this IC is the trigger. Then the output line is the pin number 3. Then pin number 4 is the reset. Pin number 5 is the control voltage pin. Pin number 6 is the threshold. Pin number 7 is the discharge. And the pin number 8 actually is the VCC or the positive side of the power supply. So we have here actually the corresponding terminals also based from this internal circuit, the complete internal circuit of this LM555. So aside from that class, there are three important modes of operation of this LM555. The 555 timer IC can be operated as a stable multi-vibrator. It can be operated as bistable. And the third one is monostable multi-vibrator. These are the three important modes of operation of this 555 timer IC. No? These are the three important operations of the 555 timer IC. That is why it is called versatile. It can create multifunctional operation. No? You can create lots of projects. Actually, the 555 timer here is operating a monostable multi-vibrator. So, we will explain this schematic circuit in detail while assembling the components, the corresponding components of this schematic diagram. We have here the actual electronic components based from this diagram. We are going to assemble them on this breadboard while discussing them one by one in detail. Okay? Okay, let us start. Okay, let us start now the activity. We are going to assemble the various components here on this breadboard. But before you install these components on the breadboard, it is but a proper procedure for us to first check the functionality of the components, whether the components are still good or bad. Although the components are still new because they are newly purchased from the electronics hardware. Because there are cases wherein, although they are still new, but there are factory defects. So this is to avoid the problem after you assemble the components on this PCB or printed circuit board or on this breadboard. Okay? So we have here, we can test the functionality of the components using the test instruments that we have here. You may use the analog multimeter or the digital multimeter, or you can also use this multifunctional tester, the latest technology of test instruments. So it is actually supplied with 5 volts. We are now connecting this power supply to the outlet. Then try to measure the capacitance of this capacitor. So, since there are two terminals, insert to the holes marking 1 and 2. 1 and 2 because there are two terminals. Either of these two here or either of this one here. So, insert one here or you may insert here. Then, this push downward this lever to permanently connect. Then, press this start. Okay? So, the capacitor is good because the capacitance given here is 475.2 nanofarad. When it is converted into micro, that becomes 0.475 microfarad. And if we are going to read the numerical code marked on the body here, it is 474. J there is more or less 5%. It is 474. The last digit here, 4, indicates the number of zeros. So there are 4 zeros. When we read them, it is 470 picofarad. When we convert that one to nano, that is 470 nanofarad. We convert it into micro, that becomes 0.47 microfarad. So therefore, this is still good or functional based from the reading here. Then, how about this diode? Since there are two terminals, use 1 and 2 again. Then, fold down the lever to permanently connect the diode. Then, press this start. So the reading here, it is good. Number 1 is the anode, and number 2 is the cathode. So this diode is good. Okay? All components here should be measured using this test instrument to verify whether the resistors, the capacitors, the inductors, the diodes are still good. So let us try this capacitor. Again, 2 terminals, 1 and 2. Then pull down the lever and press. The reading here is 98.8 ohms. That is the measured value. But when we read the resistance based from their color codes, brown, black, brown, that is 100 ohms. But there is a tolerance given here which is gold. That is more or less. So there is usually an inclination of resistance because of the tolerance. But based from this tolerance, 98.8 ohms is still good. Okay. So after the components are measured, we'll now proceed to the assembling. So we will make it sure that all the components that you are going to assemble on the breadboard are still good and functional. Okay? Okay, let us start from this power supply. Of course, we have the AC cord. Okay, we have here the AC cord. Based from this schematic symbol, the AC source from the outlet. So we are using this AC cord. So we have here the 2 terminals here. So insert these 2 terminals of the AC cord over here. Okay. 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 This represents now the AC power line source. Okay. Then you are going to connect this capacitor, 470 nanofarad or 0.47 microfarad. And you have here actually the capacitor. So the terminal of the capacitor actually is connected to the terminal here. So therefore, connect that one here. Okay. Then, across this capacitor is a resistor. And it is 1 mega ohm. We have here 1 mega ohm, which is 1/2 watt. Then, connect that one here. Okay. Remember that this capacitor is a voltage dropper. It drops an amount of voltage that there is a remaining voltage at the output. Lower amount of voltage which is needed by the load resistance here, which is the appliance protector. And actually the purpose of this resistor across the capacitor, as well what we have studied before, it is a discharger of the voltage, because this capacitor will always store voltage or charge voltage, and that voltage being stored by this capacitor should be discharged. Although the AC cord is no longer connected to the outlet, but there is still remaining voltage at this capacitor if there is no resistor here. But with resistor, the stored voltage will be automatically discharged to make us safe from the circuit, because if you happen to touch the terminals here, you can be electrified without the resistor. Okay? Then another resistor is here, which is 2 watts, 100 ohms, because brown, black, brown is connected over here. Okay? Okay. So the purpose of this resistor is actually to limit the surge current from the outlet. Of course, the 230 volts AC from the outlet will push the current to flow entering the circuit. The current might be strong, or we call it surge current. So that must be limited to avoid this problem, harmonic distortion, that lowers down the quality of the operation of the circuit. Then, there are 4 diodes, rectifier diodes, that will rectify the AC voltage into DC voltage. Wherein the specification rating here is 1N4007. What is important here is actually the peak inverse voltage, which is 1000 watts. Peak inverse voltage should be higher than the input voltage 230 volts. 230 volts is just RMS, but the peak value there is 325. Okay? So, the anode actually, this diode, the anode is connected to this two terminals, and we have here the, where is the cathode here? Okay, let us, we can use this tester to identify, because you cannot easily identify because the band here, the gray color band, was erased. So, okay, this is now the cathode and this is now the anode. So the anode is actually connected to these two terminals over here. Okay, it goes like that. Okay, then the cathode of the next diode, okay, over here, the cathode, which is here, is connected here. There are two diodes connected to this two terminals. Okay, we'll put it here. Okay, so on the other hand, this line here, cathode and anode again. So cathode, which is this one here, cathode, there is a color band, is connected here. Cathode is connected here, and the anode is over here. Okay. Then the anode again is here. Anode. Okay, let us connect it here. The anode. Okay. The anode here. Okay, we have here the anode, and the cathode is connected here. So actually, the four rectifier diodes are connected in bridge configuration. No, they are connected in bridge configuration. Okay, let us check again. Check. Okay, this is now the anode and the cathode. Then the anode and the cathode. Then this one is the cathode and the anode. Okay, they are correctly connected on the breadboard. The four diodes now are connected in bridge configuration. Okay, then what is next is the capacitor. We have here a capacitor with a capacitance of 330 microfarad and a working voltage of 35 volts. That is the appropriate working voltage and capacitance of this capacitor, because there are times that the voltage here is not only 12 volts but it will increase to 25 volts. That's why if possible 35 volts or more. Okay, then transfer here in such a way that there is space for the capacitor on the Zener diode. Okay, transfer it here. Okay, we will now connect this capacitor. The positive side is over here, and the negative side is over here. Okay, the positive side is connected to the two cathodes, and we have here actually the two cathodes. Then finally the Zener diode. Okay, we have here a Zener diode. Let us check again if this is still good. Again, 1 and 2. Pull the lever down to permanently connect or hold the two terminals. Then, it is good. We have here the cathode, and number 2 is the anode. Okay? Release by pulling upward the lever. So, the cathode is over here. It should be connected to the positive side. So, the positive side is actually over here. And the negative side is over here. Okay. Okay. So, let us check again whether the components are correctly connected on the breadboard or to the breadboard. Okay. Okay. Let us check whether there is an output voltage across the capacitor or the Zener diode. Remember, Zener diode here is a voltage regulator, wherein the voltage rectified by this diode and smoothed out by this capacitor will be made constant. There will be no more variation of voltage. That is to avoid noise or hum. Okay, let us connect to the outlet. So, observe if there is explosion. So, let us measure the voltage here. Set it to voltmeter. Then DC. We are now at the DC voltmeter because the output voltage actually is no longer AC. Although the voltage at the outlet is AC. But after rectification and regulation of the circuits, it is made DC. So, it should be DC, no? So, it is 12.70 volts. We have here. Okay. 12.7 volts. Because this Zener diode will regulate 12 volts. Then, if it is AC volts over here, AC. Is this AC? 238 volts AC. Across this one here, across this, at the input of the rectifier, the voltage here is still AC. Let us make sure. It is 15.61 volts. Because the other voltage is dropped by this capacitor. And only 15 point something volts is at the input of the rectifier. And finally, the output here, it has set it to DC, is 12 volts, which is required by this appliance protector circuit or the 555 timer circuit. Needs only 12 volts, and the current rate is 0.055 milliamperes, 0.055 amperes or 55 milliamperes. The amount of the current that will be distributed here and the voltage that will be supplied here is 12 volts, because this 555 timer IC can be supplied with a voltage of 4.5 volts up to 15 volts. Okay? And we have here actually the 12 volts. So that is the way how we make it sure that before we connect the voltage here to the LM555 or 555 timer, see to it that the voltage is correct and stable. Okay?